And then you should also be able to tell me, um, like, what do you know about those two shapes specifically, being able to find angle measures and then find sides using the rules for similarity. Okay, so number one, we talked about this yesterday. Remember that similar means that they have the same shape, but they are not necessarily the same size. Okay, the symbol is this little tilde on your computer there. If you guys have it at home, it's right next to the number one. It's the top part of the congruent symbol, right? Remember congruence? We just do the squiggly part. That's the symbol for similar. If you remember, what do we know though when they tell us that two shapes are similar to one another? What does that actually tell us, Max? Okay, so one thing it tells us is that the corresponding angles are congruent. And the other thing that we know is that, besides the angles, what else do we know? Think about when we did construction like this one or this one, right? Annika? Good. And so that when they're dilated by the same rate, to us, that tells us that they are proportional. So the fractions for the sides are going to be equal. So we know that the sides are proportional. As soon as I know that these figures are similar, I know that those two things have to be happening. Okay? They're guaranteed to happen. Now, on your chart here, it says right here, if similar polygons, corresponding angles are congruent, okay? Corresponding sides, proportional. Those are the two things I know. What that tells us is, when I look at how these figures are named, okay, the first letter in the first one goes with the first letter in the second one. So A and G, those angles are equal, okay? When you look at the diagram, the angles that are in the same position, those angles are going to be equal. So angle A and angle G, B and H, C and I, D and J. And the corresponding sides are equal. So AB, which is over here on the left, corresponds to GH or HG, and I can make a ratio with those two sides. Does that make sense? That ratio is also going to be the same if we compare BC and HI, because we're multiplying by the same scale factor, right? So if this was, let's say, 3, and it's a scale factor of 2, this is 6. If this is 2, this is 4. They always have to equal that, whatever that number is that you're multiplying by. And that's also true if you flip these upside down. So GH, right, over AB is also the same as HI over BC, which is also the same as IJ over CD, which is also the same as GJ over AD. So even if you did the reciprocals of these, you'll still get the same number. Does that make sense to you guys? We're good with that? We talked about those scale factors yesterday. That's all we're doing here. Okay. Similarity statement. This is an example of a similarity statement right here. Triangle ABC is similar to triangle XYZ. Just like when we did congruence, we just put the squiggly in between them. It means they're similar. Okay? Make sense? All right. Remember, what does it mean when it tells us that these triangles are similar? It means two things. All their corresponding angles are equal. So A is equal to X, B is equal to Y, C is equal to Z. And that tells us that if I make what's called an extended proportion, okay, a ratio using the sides, AB over XY, BC over YZ, AC over XZ, it's equal to the same number. They're always equal to the same thing. So AC over XZ, okay, AC is 25 over 10 is equal to 5 over 2, which is 2.5, okay? And if I pick two other sides to compare, let's pick a side. Shaja, give me another side over here in the bigger triangle. AB. So AB over, and Duncan, AB goes with XY in this triangle. Okay, so 15 over 6 Guess what that's equal to? What goes into both 15 and 6 evenly? A 3. This is also 5 over 2, just like this one was, okay? And we can also see that if we compare BC and YZ, right? BC over YZ gets us 20 over 8. And guess what that's equal to? That's also 5 over 2. So it doesn't matter what corresponding side you pick, you're always going to get that same ratio. Make sense? So what happens if I had a question where they didn't give me this? Right? What would we do? Well, I could just create a proportion, okay, and just solve using that proportion. So I could say 15 over here over 6 here is equal to AC over XZ, which is 10. And then how do we solve an equation that looks like this? You just cross multiply. That's it. That's all we're doing today. What's going on? Thank you much. Okay. Does that make sense to you guys? So if we cross multiplied, we get 150 equals 6, and divide by 6, we would get 25. Okay? So that's how we would end up finding that number. Does that make sense, everyone? Questions? Pretty simple. Nothing too crazy. That's all we're doing today. Okay? We're on page 7 in your packet. All right, so let's take a look at the understanding similarity part. What I want you guys to do, okay, is give me the pairs, of course, of congruent angles. So you could say like angle M is congruent to angle what? Angle N is congruent to angle, and angle P is congruent to angle. And you can fill in those blanks. Okay? What are the extended proportions? Now, you and your neighbor may give me different proportions here, like the order may be different or they may be upside down, but you should be consistent. So that means if you go from the small triangle to the big triangle, you have to do that in every single ratio. If you choose small on top, every single fraction has to have the small sides on the top. Does that make sense to you guys? You can't do small over big and then big over small. It's got to be consistent. Okay. Nope, as long as it's all the same. Okay? Because remember, if you do the reciprocals, right, you're still going to be equal. They're still going to be equivalent. Okay? But they have to be consistent. You guys are currently filling in, okay, A and B here. And see if you can do number 3. You can try 3. So for question B, remember, you're filling in what over what equals what over what equals what over what here. Okay? All right. Ian, angle M was the same as angle. Very good. S. N. Prime time was the same as R. Good deal. And then P is the same as, hopefully you got T, right? Okay. Remember, all we're basically saying is if I took this triangle and got it to fit on top of that one, which ones are going to overlap, right? Which ones are in the same position, essentially. Okay, so what did you pick for your ratios here? What did you pick for your ratios? Go ahead, give me the first one. You said PM? N, got it. Over TR. Okay? So, PN. Perfect. So we're comparing PM to TR. That is a totally fine. Now, once Annika picked that ratio, she has set the order the other ones have to go in, okay? I automatically know that I have to have a certain one on the top here, right? So, Will, what did you put down for your second ratio? Okay, so MP over ST. Does that fit the same, right? Small over big, we're consistent, we're good. Okay. And then either what about the last one here? So what other two sides have we talked about? And then which one goes in the top versus the bottom? So remember, see how we had PN, which is the smaller triangle on top, MP was on top. So in other words, we're saying we have to do the small on the top and then the bigger one on the bottom. Perfect. We just have to be consistent, okay? So once you set the small to be on the top, it has to always be small on top. Make sense? If you had given me TR or PN, or if you did these in different orders, totally fine. So either you have the reciprocals, or you have these, or they're just switched around in different order, you're good. All right. Did anyone get an answer for X on this one? Okay. We're going to do, let's just make, I'm going to make a line down the middle here. Okay. There's two ways to do this that you're going to figure out as you go along here. Okay. The first one is going to be with a proportion. And the second way is going to be with a scale factor. I do not care which one you pick. It's totally up to you. Okay. So what have we been doing this whole time? We've been making proportions, right? So if I was looking to figure out what X is, okay, what X is, Duncan, when I look over at this figure and I see that this is X, what side corresponds to X in the other shape here? BC. So I'm going to make a fraction using these two sides. So what over what here, Duncan? It doesn't matter. But remember, use the expressions of the numbers here. So we're going to say x over 7.5. Duncan could have said 7.5 over x, but he said this. You're not wrong. Totally right. As soon as Duncan says that, though, he's setting the order for our fractions. Everyone understand that? So the next fraction I have to put down has to be smaller over bigger automatically. Okay? Now, what we want to do is ask ourselves, what other two sides do I know the values of? Don't pick another variable. We know. Now remember, we don't know EF because it's a variable. So don't choose this one. We want to choose ED because that's 6, right? And that goes with the whole side here, which is yep. And then the other one is what's the other side that corresponds to the 6? The whole thing, right? So if this is 6, what side corresponds with it? The 9, right? And then you just got to make a fraction there. So this one needs to be 6 over 9. That's it, 6 9. And then what do I do once I have my fraction? Cross multiply. So we do 9 times x, and we put that where the x is. So that's 9x. And then 6 times 7.5 is 45. So we just divide out by 9, and we get x is equal to 5. Okay. Remember yesterday, we talked about how to figure out the scale factor, right? So if I look at these two shapes, If I want to go from the smaller figure to the bigger figure, what would the scale factor be? What's my R value? What do you think? Max, how did you get that? Okay, good. So 9 over 6, right? 9 over 6, and that's just 1.5. Does this make sense? 3 over 2? So any side, if I multiply any of the smaller sides by 1.5, I automatically get the bigger side. Now, this is going from the small to the big. What's the other scale factor I have, though, if I want to go from the big to the small? Instead of saying 1.5, I'm going to leave this as just 3 over 2. So what's the scale factor if I want to go from the big figure to the small figure? Duncan? What is it? If this is 3 over 2, this one is 2 over 3. You just do the reciprocal. So if I know that this side is 7.5, if I'm using my scale factor method, I just take x, I took the corresponding side, and I multiply it times 2 over 3. That's it. You're done. That's all you have to do, okay? 7.5 times 2 is 15, and then 15 divided by 3 is 5, and I still get x equals 5, okay? Does that make sense? So you can either use your scale factors or you can use for your proportions. I do not care which, you pick, okay? So if I were solving for y, Natalie, which method do you like to use? All right, what proportion would we create to solve for y? Good, equals. You could still use the same one we used on the first question. 6 over 9, good. Notice that y is from the smaller figure, so we have to do smaller over larger, and then we just cross multiply and solve. So 9y is equal to 30. This one's not going to come out to be a whole number. That's okay. You can say 30 over 9. You could reduce down to 10 over 3. You can say it's 3.3 repeating. Whatever you want to put down as the equivalent answer. Cool? All right with that? 3 1/3, 10 over 3, your call. So can we use the same approach for the scale factors? Sure, right? If we take 5 and multiply it times 2/3, 5 times 2 is divided by 3 is still 3.3 repeating. So we know y would equal 3.3 repeating, okay? So you can use scale factors or proportions. Pick one, stick with it, whatever you feel comfortable with, okay? Questions for me on this? All right. All right, let's see if you guys can try number 4 here. You guys need another minute, or are we good? If you want another minute, put a finger in the air. All right, take another minute here. So once we know the corresponding angles are equal, 35 for angle E, 35 for angle R. If angle Q is 89, then F is 89, right? And now we can use these two angles to figure out the third angle, okay? So 89 plus 35 is 124. And so take away from 180 and we're left with, Maggie, we're left with 56. Okay. And then we can also fill in the other angles here, right? Angle R we know is 35. Angle P is 56 as well. Okay. And then how are we figuring out the length of DE here? We think enough. What do we do for this one? Or what can we do? If we know the sides are proportional, we can make a proportion, right? So what sides do you know the lengths of? What corresponding sides? So we need a fraction. We're going to say 24 over 20. As soon as you set 24 over 20, it's got to be big over small for this one. So if we're looking for the length of DE, we'll call that, I don't know, we'll call it X if you want. Then this one has to be X over 40. Good. So big over small, big over small. Now we just cross multiply and solve, right? So 20X is equal to, what is this? 4 times 24, 16, 8, 9, 60. Sound about right? Divide by 2, 0, because we're dividing by 20 here, and we're left with 48. Okay? And then we're looking for FE. Feel free to call this Y if you want, or you can just use it as FE, right? We can still use the same ratio that we got before, okay? Does it make sense? 24 over 20, that's the one enough used. And this time we're going to do, how about 36 over Y? Does that sound good to you guys? Yeah, we shook our head no for. Good. 24 over 20, it's got to be big over small again. So we have to do Y over 36. So careful that you're doing the correct order here, okay? Cross multiply, we're going to get 20Y is equal to, you guys have this one? 24 times 36 is? Did we get this far? Okay. And then final answer? All right. Like it. $864 and 43.2. Okay? Does that make sense how we did this though? Any big questions? Everyone's okay with creating a proportion and solving? Okay. Last one we're going to have you guys do. Let's take a look at number 6 here. This is a little advanced topic that we're actually going to talk about at a later date as well. Okay, this is called the side splitter theorem. The reason it's called the side splitter is, you see how this line BD is cutting through the sides of the triangle here? We're splitting the sides. And the important thing that makes it side splitter is it says that these two lines are parallel, okay? So even if I didn't know the theorem, I could answer this question. If these lines are parallel lines create congruent angles, right? What angle pairs are equal? This angle CBD would be the same as A, right? This angle at CDB is the same as E, and this angle is actually being shared between these two triangles. So I actually have triangle CBD similar to triangle CAE because their angles are all equal. Once the angles are equal, I know that they're similar, okay? So I can figure out what X is by using our proportions, okay? By using our proportions. So look at the smaller triangle, okay? And then look at your bigger triangle going all the way around here. All right? The smaller triangle has a length of 12 on the left. The bigger triangle has a length of, this is where it gets a little tricky. What's the whole side worth? 12 plus x, right? You just add together the x and the 12. So x plus 12 or 12 plus x. And then the bottom is 15, and this is 3x plus 8. So I can create a proportion here. I can say that when I compare the smaller triangle to the bigger triangle, 12 over, what's the corresponding side? 12 plus x is going to equal, and what does the other fraction have to be? Remember, we started with what triangle? The 12 came from the smaller, so we have to go back to the smaller. The other side we know here is 15, and the corresponding side is 3x plus 8. And so now I can go ahead and cross multiply and solve. We're going to do a whole day of just this, okay? So we'll come back to it, but I just wanted to show it to you because it still uses congruent or similar triangles. And then we cross multiply. So 12 times 3x plus 8 becomes, 12 times 3 is 36x plus 12 times 8 is 96. Okay. 15 times 12 is 180. And then 15 times x is just 15x. So now we're going to get all the x's on one side by subtracting. Okay. And we're left with what? 21x plus 96 equals 180. Move that 96 over. 21x is equal to 84. Last step, get the x by itself by dividing, and we get left with x is equal to 4. Now, be careful. Question doesn't say find x. It says find AC, right? So if this side is 4, that means that AC is equal to 4 plus 12. So AC is 16, okay? This is an old Regents exam question that they've asked in the past. So you get an idea of like what they're looking for here, okay? Make sense? So remember, side splitter we'll get to. When the line's drawn parallel, we get two similar triangles. We just do a proportion between the sides, and we cross multiply it out. We good? Okay. The other thing we're going to do today is word problems. I would really like you to take a look at the bottom of page 9, and let's talk about Marquise and his building question here. Okay. These questions that we're going to take a look at today are going to be using similar triangles. Now, back in the day, okay, they could be able to estimate the Egyptian pyramids. Do you remember how do you guys ever hear about how they were able to do this? They could figure out how tall these were, even though there were little people way down here. Any ideas how they could do it? Math. Nice. They take a stick and they put it on the ground, right? And the stick, when the sun is shining, has a shadow. Okay? I know the height of my stick, right? And I know the length of my shadow. Okay? So if this is A and this is B, and the pyramid, guess what that has? You guys get this. It's got a shadow, right? And so I would know the length of their shadow, and I could use the fact that I'm getting similar triangles here, okay, to then figure out the height of the pyramid, because I can measure these things, and then I know because the sun's direction creates the same angles. This angle is the same as this. They're sharing an angle, okay, and therefore the triangles are similar and we can solve. This is essentially all we're doing here is the same type of question. Now, Marquise, okay, is standing, we're at number 9 down here, standing down here, the bottom of our triangle, and he looks up and notices that as he's looking up, the top of the flagpole lines up perfectly with the top of the building, okay? He knows that he's 60 meters away from the flagpole, and he knows that the flagpole is 35 meters high, and he also knows that he's exactly 170 meters from the building. So can we figure out how tall the building is? This question is really a disguised what? Similar triangle question. Do you see the two triangles? Okay. Why do we know they're similar? The assumption here is that the building is standing perfectly straight, and so is the flagpole. And we have a shared angle where Marcus is standing, so that if we have angles of a triangle, we know what these two angles are going to be as well. Okay? So once the angles are equal, the triangles are similar. Does that make sense? How do we solve for the sides of a missing triangle? What have we been doing all day? Stare at it until the answer magically appears. Get out of town. What do we do? We make a. What did we do for the last question that we did? We were trying to find the side. We made a. What's this called? What's this called? What's that called? Oh, we made a proportion. We're still going to make a proportion here. Now, what I want you to see, though, is a few things. Number one, for letter A, it says, are the triangles similar? We can say yes. Okay? Why are they similar? Because their corresponding angles are congruent. Because the building and the flagpole are standing straight, creating parallel lines. Okay? And then we have our corresponding angles that are equal and a shared angle. Determine the height of the building, knowing what we know about scale factors. So when it says scale factors, and I'm not going to specifically ask you for a method on the test or the quiz, I want to know what is my R value. Does that make sense so far? So looking at the two triangles, okay, what two sides do I know the values of here? What two corresponding sides do I know the values of? Malia? So I have a 35 in the flagpole. Do I know the side in the building that goes with that corresponds? Nope. I have a 60. Do I have the same corresponding side here? Okay, so let's make a fraction. So 60 over 70, 170, sorry. This is going to get from the, is this going to get larger or smaller if I multiply by the scale factor? Which one's on the top? Smaller. So this is going to go from the big to the small. It's going to get smaller. So if I want the scale factor, because I'm looking for h, I don't want to use this fraction, this ratio. I want to use 170 over 60. This is going to go from the smaller figure to the bigger figure. What side do I know already that corresponds with h? 35. And I'm going to multiply that times my scale factor, which is 170 over 60. That's it. So 35 times 170 is numbers, math, as we would say, right? $5,950. And then we just divide that by the denominator of 60. This comes out to be a decimal, but it's 99.16 repeating. The reason why I'm writing this out and not like 99 if I round it is because it doesn't say what to round to. So I'm going to give it the most accurate answer I can. Okay. On the next page, the question says, determine the heights of the building between using ratios. So ratios basically means make a proportion. So what proportion could we make here? Pick a side in one of the triangles. What do we think? Haven't heard from. Oh, go for it. 170 over 60 equals. Now remember, h over 35. So did we pick consistent? Are we doing big over small, big over small? Right? Yes, we're good to go. Now we cross multiply and we're all set. So we get 60H equals, we already know that this is 5,950. We did that math before. Divide by 60 and we're left with, get this guys, 99.16 repeating. Okay. Now, the last option says that it wants ratios within the similar figures. So this time, I want to make a ratio using just a small triangle. Okay? The whole point is this. You can make a whole bunch of different ratios. How do we know if they're all going to work? Right? If I made a ratio using 35 and 60, I could write down 35 over 60. That has to equal what in the other triangle? Be consistent. Okay, does this work? If we put 35, good. Notice that 170 is not the corresponding side, so we want to flip that around and say h over 170. When I cross multiply, do I still get the same result? I'm still multiplying 135 or 35 times 170 either way, right? This is still going to be 5,950, and this is still going to be 60h. So here's the deal. When you walk in the door from doing your homework tomorrow, and I have you like compare an answer with your neighbor, even if your proportions are not the same, all you need to do is look at your cross products here. That's supposed to be the wrong thing. All you have to do is look at your cross products and see if you guys got the same multiplication answer after you cross multiplied. If you did, your proportions are totally good. They're equivalent. Okay? Does that make sense? So just if you're checking with your neighbor, you don't have the same ones, are the cross products the same, you're good to go. So for homework tonight, on page 12, you guys are doing number 1 and 2. For number 1, I need to give you the triangles because I did not get put on here. So draw yourself 2 right triangles here. All right. This is just going to be, before you guys are out of here, A, B, C, and then X, Y, Z. And now let's just do 3, 4, 12, and 15. Okay? You should be able to answer all the other questions you need. Have a great day, guys. We will see you all tomorrow. And I'll send the video out just in case you get stuck. Homework page 12. Have a great day.